Alright, so we'll start with number 3 now. And we're starting with this concept called GCD, LCM. So basics you already know. So what is GCD? It is the greatest natural number which divides them both. LCM is the least natural number which is divisible by both. So again, you have done these concepts since time immemorial, since you are in class 5th, 6th, 7th. When does this come? Class 5th, class 6th, class 4th. Okay, all right. So co-prime numbers, two natural numbers are said to be co-prime if they have no common divisors. For West Bengal, it is class 2. So if there are no common divisors, they are said to be co-prime numbers. 9 and 16 are co-prime. 6 and 15 are not, because GCD of 6 and 15 is 3. Any two consecutive integers are always co-prime. So GCD of n and n plus 1 is always 1. And any two consecutive odd integers are always co-prime. Right, so we'll be proving this using the properties that we're going to study. For two numbers, GCD of AB and GCD of LCM of AB is always AB. So product of two numbers is always equal to the product of their GCD and LCM. This only and only happens for two numbers. Is it clear? Now guys, so we all know how to find the GCD LCM using prime factorization, using Euclidean algorithm and so on. But we will be studying and go deep down into properties of GCD LCM, which makes a lot of sense as far as IOQM is concerned. And of course, these are the properties which are normally not discussed in your school curriculum textbooks, but it should be there. I mean, these are such awesome properties. They're such powerful properties that you get to learn a lot of things after learning and applying these properties. For example, the first property is if GCD of AB is 1, of course A and B are integers. Then GCD of A comma B plus AN or GCD of B comma A plus NB is always 1. Can anyone prove this? Can anyone prove this? Can I unmute anyone who would want to help prove? Yes, we can use yes EDL. We can use, right. So normally these kind of things are usually proved using contradiction, right? So try to inculcate this concept called contradiction. So GCD of AB is 1. So it is given that the two numbers are co-prime to each other. We need to prove that GCD of A, let us pick any one. Yeah, take a minute. Don't worry. The hint is use contradiction. Yes, Sanskar, we will be proving this for all others also. But for now, just prove it for one. Mm, exactly. So assume that GCD of A and B plus NA is D, which is greater than 1. We assume that the GCD is D, which is greater than 1. So one important thing when we assume the GCD of A and B, and it is very important, guys. It is very important. Let me go back. So if two numbers A and B have a GCD, let's say D, then A can be written as a multiple of D and B can also be written as multiple of D, where and it is very important, X and Y, anyone on the chart, are co-prime. Now, this is the most important condition, guys. Because if X and Y are not co-prime, X and Y have something in common, then that something can come out and it is going to get multiplied by D, and GCD is not going to be D, it is going to be more than D. This is very important, guys. Okay. Now, if these two have GCD D, then can I say A is D times X and B plus NA is D times Y, where X and Y are co-prime. Where X and Y are co-prime. Is this clear? Is this clear? Now, in this case, guys, B, can I write that dx minus NA? Dx dy minus n times A is dx. So D can be taken out, it is y minus nx. And this shows that B is a multiple of D. A is already a multiple of D. B is also a multiple of D. That means GCD of AB is not going to be 1. Is greater than or equal to D. Minimum it is going to be D because D already has been taken out common, which is clearly greater than 1. So GCD of AB is greater than 1, which is a contradiction. So D has to be 1. If these two are co-prime, A and B are co-prime, then A and B plus NA have to be co-prime. Very important. Yes, same way we can prove this. Is it clear? So this is very important, guys. Very important. If two numbers have GCD 1, then A plus second number plus any multiple of first number is always going to have are going to be co-prime. Let us take a feel of this. Feel. Feel. So if X and Y are co-prime, then can I say X and X plus Y are also co-prime. X minus Y are also co-prime. X plus 2Y are also co-prime. X plus NY in general is always going to be co-prime. Is this clear, everyone? If two numbers are co-prime, then the two numbers, then any one of the numbers with their sum is also co-prime. Any number with a difference is also co-prime. Is it clear, everyone? Is it clear, everyone? Right. So this is a very powerful property, very important property. Always remember this. Alright. Now, guys, of course, यहाँ पर we have taken n. So n can be any integer, no? So if we put n as 1, it is going to be a plus b. N as minus 1, then b minus a. Nihal, this is not inequality. See, Nihal, if I say a is a multiple of 3, b is also a multiple of 3. What is the GCD of AB? First of all, can you pinpoint the GCD of AB? Can you carefully say that GCD of AB has to be fixed only? If both of them are multiple of 3, right? So can I say, see, minimum it is going to be 3, but it can be more than 3 also. Is that right, Nihal? So this is A is a multiple of D, B is also a multiple of D. Then GCD of AB, minimum it has to be D. It can be more than D also. And D is greater than 1. This is the assumption. Hence, GCD of AB is greater than 1. This is not true. Clear, Nihal? Alright. Next property is GCD of AB is same as GCD of A, comma, NA plus B and B, comma, A plus NB. Very powerful, very important. Let's try to prove this. I'll give you around 2 minutes. Use the property, Sanskar. Use the property, no? GCD of AB. So let's assume GCD of AB to be D. Then A is equal to dx, D is equal to dy. No yukti. It wasn't before, the same as before. Before, what we did was A and B are co-prime. So what we did was A and B are co-prime, or two numbers are co-prime. Then number and the sum of the numbers is also going to be co-prime. Number and the difference is also going to be co-prime. This is what we did earlier. This is different. It says whatever the GCD is, GCD of these two is going to be same as GCD of these two is going to be same as GCD of these two. This is different. So let's assume the GCD of A and B to be D. A is dx, B is dy, and hence x and y are co-prime. X and y are co-prime. Is it clear? Now let us pick A and NA plus B. A and NA plus B. Now A I can put dx and dy plus, sorry, NA plus dy. Now in both of these terms, what can I take out common? In both of these terms, what can I take out common? I can take out d common. D times x comma nx plus y. Now guys, if GCD of two numbers is 1, what is GCD of x and nx plus y? You've done this before. So it is going to be d times 1. Now you got the importance of this property, guys, that we just did before. So that property, that means GCD of xy is 1, implies GCD of x comma nx plus y is also 1. This property is basically getting used to prove this result. Is this clear, everyone? So GCD of A and NA plus B is also going to be D. Is it clear, everyone? Right, so this is how we go systematic wise. So this property, if two numbers are co-prime, then x and nx plus y is also going to be co-prime. This is getting used to prove this property. Clear, everyone? Clear, everyone? Now guys, this is a very important property. Yes, Sanskar. So basically, if you prove this, so this is all automatically proved because this is a symmetric equation. Exactly. Now, so what we've done is we've been able to prove that GCD of AB is same as GCD of A, B plus NA. Special cases. So if I put N as 1, so GCD of AB is same as GCD of A, comma B plus A. It's same as GCD of A, B plus 2A. A, B plus any number, 5A. If I put N as minus 1, assuming B is greater than A. So this is also same as GCD of A, comma B minus A. So what is this property doing? So this property is lowering down the numbers. This property is lowering down the numbers. And we are more comfortable with smaller numbers, right? So it is easier to add 5 and 7, and then maybe add 35 and 47. Right? Of course, you can do both. But 5 plus 7 is on your tips. So smaller numbers, we are always very comfortable. And this property is lowering down the numbers. For example, if you want to find the GCD of 12 and 15, maybe I have to use a Euclidean algorithm or maybe, prime factorization. But if you apply this property, smaller number as it is, bigger minus smaller. So GCD of these two numbers is same as GCD of these two numbers. Isn't it? And we know that 12 is a multiple of 3. So GCD is going to be 3. And this is the answer. Right. So this is a very powerful tool, very important tool, very powerful tool which helps us a lot in these kind of questions. Is this clear, everyone? This is very interesting, guys. Is this clear, everyone? On the chat? Is this clear on the chat, everyone? Yes, yes, yes. Exactly, Parth. This is essentially Euclidean's algorithm only. But again, in books, this is not taught. How is it? What is the proof of Euclidean algorithm? So this is kind of proof of Euclidean algorithm. All right. And see if there are bigger numbers. Let's say we have to find GCD of maybe 10 and what 25. So what I'll do is 10, 25 minus 10. Instead of doing minus 10, I'll do minus 2 times 10. So 10 and 5, which is clearly 5. Okay. Now let us try to find GCD of these two numbers using the same trick. So we have 4840 and 1512. So these two are big numbers. So instead of prime factorization, what we'll do is 4840, smaller number as it is. So we'll put smaller number as it is. So 4840 minus what times 1512, guys? What should I multiply 1512 with so that it becomes as small as 3? Perfect. So 4840 minus 4536. So it is 304. So this is same as GCD of 304 and 1512. And clearly this is a multiple. 1512 is a multiple of 304. So GCD, is it? No. Oh, sorry, it is not a multiple. I thought it is 1212. So again, we'll keep smaller number as it is. 1512 minus what times 304, guys? Minus what times 304? So 4 times 304. So 1512 minus 1216. It is going to be 296. So GCD of 304 and 296. Smaller number as it is. Bigger minus smaller is going to be 8. And is 296 a multiple of 8? Yes. 296 is a multiple of 8. Hence, the HCF is going to be 8. Is it clear, everyone? Is it clear, everyone? This also explains the fact that two numbers which are co-prime to each other. Right? So small number as it is, bigger minus smaller is going to be 1. So n and 1, GCD of course is going to, so one number is 1, of course the GCD is going to be 1. Is it clear, everyone? GCD of 13 and 15, or for that matter GCD of 203 and 205. So small number as it is, bigger minus smaller is going to be 2. Bigger minus smaller is 2. So their GCD is same as GCD of 203 and 2. This is odd, this is even, so GCD is going to be 1. Again, so it is not going to be 2. This is odd, no? This is even. So GCD is going to be 1. Is it clear, everyone? Is it clear, everyone? Alright, prove that the fraction 10n plus 1 upon 30n plus 2 cannot be reduced for any natural number n. They can't be cut. In other words, what we need to prove? To prove, yes, they are co-prime. 2n plus 1, 12n plus 1, 30n plus 2 are co-prime. So let's use the property. Clearly small number as it is, bigger minus smaller. So 30n plus 2 minus what times the smaller, guys? What times? 2 times the smaller number. So this is 12n plus 1, 30n plus 2 minus 24n. So it is going to be 6n. 6n, that is it. Smaller number as it is, bigger minus smaller. It is going to be 6n plus 1. And clearly these two are consecutive numbers, so GCD is going to be 1. And that. Is it clear, everyone? Is it clear, everyone? Right, it's a beautiful property, guys. It's a lovely property. Now, guys, one more thing. So if the two numbers, let's say A and B have a GCD D, then clearly A is dx, B is dy. The important condition, again, this is very important condition which is not to be overlooked, is GCD of x and y are 1. Now, on the chart, can anyone tell me what is going to be LCM of A and B? What is going to be LCM of A and B? It is going to be dxy. Right, see, if one number is 3 into 7, the other number is 3 into 5, then LCM of A and B is going to be 3 into 5 into 7. Right, so 3 common and 5 into 7. Because x and y are co-prime. So if two numbers x and y have a GCD of 1, then LCM of xy is going to be x into y. Is it clear, everyone? Alright. So let us look at a question based on this. I'm making a chart private. I'm giving you 3 minutes. Yes. Sanskar, there are a lot of questions in IMO, USMO, INMO based on this. So determine all the positive values of m plus n. Mn are positive integers satisfying. LCM of Mn minus GCD of Mn is 103. You can put your answers on the chat. Yes, Sanskar. So yes, move ahead. Try to solve the answer completely. So all the possible values of m plus n is what we require. Okay, so Mahavir, Sanskar says 206103. Alright, so opening the chat now. Alright, so yeah, Ishan, do that. 210. Suradeep says. So guys, this is what we need to be careful about, because in IOQM these kind of questions are going to come. It is not like RMO. So RMO, I would say that it is kind of easier, right? So even if you write one answer, you'll at least get partial marking. IOQM is kind of difficult because you have to look at all the possible pairs, and if you miss out on any, you're gone. Sanskar, see, m plus n is what we need to find out. Alright, so let's start. So whenever we are given GCD, we always start with this. Let's say GCD of M and N is D. Okay, so M is dx, N is dy. Important point to note is x and y are co-prime. What is LCM of M and N? On the chart, everyone, it is going to be dxy. So dxy minus d is 103. Or d can be taken out common. Xy minus 1 is 103. And the good part is 103 is a prime number. 103 is a prime number. That's a good part because it is going to be split in very, few ways. So what are the possible values of D? What are the possible values of D, guys? So D can be either 1 or D can be 103. D can either be 1 or 103. Now if D is 103, so we have 103 times xy minus 1 is 103. That means xy minus 1 is 1, giving us xy as 2. So product of two numbers x and y is 2 and x and y are co-prime to each other. This is important. So what are the possibilities? The possibilities are 1, 2 and 2, 1. Only two possibilities. And both of them are going to give the same value of m plus n. For example, in this case, first case, so m is dx. M is going to be 103 into 1 and n is going to be 103 into 2. That is 206, 103. So m plus n is going to be 309. So this is one of the values. In fact, 2, 1 is also m plus. So m and n values are going to get reversed, but m plus n is going to be same, right? Okay. Now in this case, guys, if d is equal to 1, let us look at the second case. If d is equal to 1. So if d is equal to 1, xy minus 1 is going to be 103, giving us xy as 104. 104 is 4 times 26. Or 8 times 2 to the power 3, 13. So what are the possible values of x and y? X and y should be co-prime. This is important. X and y should be co-prime. So one of the values is going to be this 1 and this 104. What is the problem here? Tanishka. Can't it be 104 and 1 or 104? The other is 8 here, 13 here. 13, 8. So in both of the cases, even though m and n are going to get reversed, but m plus n value is going to be same. So in this case, d is 1, x is this, y is this. So can I say m is going to be 1 into 1, n is going to be 1 into 104. So answer is going to be m plus n is going to be 105. So 105 is another value which can get obtained. The third value is going to be 13 plus 8. That is 21. So these are the three possible values of m plus n. Is this clear to all? Is this clear to all? So three possible values of m plus n. Yes. And if you see the history of IOQM exams, it is these kind of problems only which have been coming. Okay. Yeah, so 22, there were two problems based on this. Alright, so before we move on to the next problem, so this something called Simon's favorite trick. Right. So does anyone know what is it? Okay. Can I unmute? Who do I unmute? Sanskar Singh, his favorite too. Yes. So basically, guys, whenever you have xy with any coefficient of x, let's start with x and y is, let's say, constant. You should know and you should be able to factorize this part. So from the first two terms, if I take x common, it is going to be y plus 1, and I need y plus 1 here. So y plus 1. So adding 1 on both the sides, because this 1 we added to factorize. So x plus 1 into y plus 1 is k plus 1. So whatever the coefficient of x, y, x and y is, you will always be able to factorize. Yes, kind of, Nihar. So if we have xy minus 2x plus 3y is equal to 7. Can we factorize this now? Can you try and factorize this? So from the first two terms, x common, y minus 2, and 3 common. So we have y, we need y minus 2. So in a way, you have subtracted 6. So subtract 6 from right hand side also. So x plus 3 into y minus 2 is 1. Is it clear, everyone? And whatever the question, see, 2xy minus 3x plus 4y, you shouldn't be afraid. Whatever the coefficient of xy, whatever the coefficient of x, whatever the coefficient of y, you should always be able to factorize this. Right. So on that note, let's start and do this problem. So Pragyanju, from now on, you should not be. So guys, so whenever in a question we are given LCM, GCD, we always start with GCD. So let the GCD of A and B is D. So A is dx, B is dy. A is dx, B is dy. Alright. Okay. So this is alright. Now, how do we proceed? So A into B is dx into dy plus 63 is 20 times dxy plus 12d. 12 times d. So how do we proceed now? We'll do multiple approaches. Yeah, take your time. Take your time. Instead of dividing d, we can take d common, right? So d common, so it will be dxy minus 20xy minus 12 plus 63 is equal to 0. One is the same thing, no? It is d. Let's check. Not sure. So again, are we clear about this, guys, first of all? So if we take d common, so dxy minus 20xy minus 12 plus 63 is equal to 0. Okay. Or maybe take everything to the other side. So d times, it is going to be 20xy minus dxy plus 12 is equal to 63, isn't it? So product of these two factors, these two integers is 63. So what are the possible values of d, guys? What are the possible values of d? Possible values of d. D can be 1. Why? D can be 3 also, no? D can be 9, 7 also, 9 also, 21 also. No? 63 also. But again, don't you think it is going to become lengthy by checking all these values of d? By checking all these values of d, it is going to be lengthy, because if we put d is equal to 1 here, then 20xy minus xy plus 12 is equal to 63, and so on. It is going to be lengthy for all the cases. Don't you think? Don't you think, guys? Yes. Bracket simplify you can do, but again, Tanishka, whatever you do, it is going to be lengthy, any case. Right, so in these cases, so you don't have to always go and carry on. So think of something else. Can you think of something else? Right, so this method is clearly not working. This method. So normally what we do is, this is what I've told you. This is what I've told you. Normally, whenever GCD is given, you start with this. But again, this method is lengthy. So what you do? See, guys, two numbers, A and B. So let's give a short name to LCM, short name to GCD. So let LCM is L, GCD is D. For two numbers, can I say LCM is always going to be a multiple of GCD, first of all? LCM of two numbers is always going to be a multiple of GCD. Also, guys, for two numbers, A into B is also L into D. For two numbers, A into B is always L into D. So, can I say L into D plus 63 is 20L plus 12D? Is this not simple or better? A into B is clearly L into D. For two numbers, it always holds true. Nihar, for two numbers, this is what you said in class 3rd, 4th, 5th maybe. The product of two numbers is same as the product of their HCF and LCM, no? The product of two numbers is same as the product of the LCM and GCD. Oh, they didn't teach you. Oh, then Nihar, what you need to do is you need to prove this first of all. So before applying anything in mathematics or in life, you need to prove. Oh, yeah, how can this happen? They didn't teach you. How can this be, guys? No, you're lying. If 12 is 2 square times 3, 15 is 2, 3 times 5. What is LCM of 12 and 15? Did I tell you that you have to take the maximum powers? So LCM is going to be 2 square into 3 into 5, isn't it? GCD of 12 and 15, you have to take the minimum powers common and 3 to the power 1. So if you multiply them all, it is going to be same. So LCM into GCD is 2 square into 3 into 5, which is 2 square into 3 square into 3 into 5. And this is A into B also, 12 into 15 also. Right, so even we discussed this in today's class, no? So this is only true for two numbers. Please make sure. So this was lengthy. So what we did was we shifted to other approach. So LD minus 20L minus 12D plus 630. So L D minus 20 minus 12 D minus 20 plus 63 is equal to 240. So what we have here is L minus 12 D minus 20 is what? 240 minus 63. What is 240 minus 63? It is 177. 177. Now guys, 177. Can we factorize 177? It is multiple of 3. 3 into 59. Sanskar 59 and not 53. Now, can I say L is definitely greater than D? So what are the possibilities? So one possibility is 177 here and 1 here. 59 here, 3 here. Can I say these are the only two possibilities? L is greater than D. So 177 here, 1 here and 59 here. So case 1. L minus 12 is 177, giving us L as 189 and D is equal to 21. Case 2. L minus 12 is 59. L is 59 plus 12 is 71 and D is 23. Now, it is also important that you should know that L is always a multiple of D. LCM of two numbers is always a multiple of GCD. LCM of two numbers is always a multiple of GCD. So can I say second case can't happen? Second case cannot happen. That means for two numbers, the GCD is 21 and LCM is 189. So let the numbers be 21x, 21y, and x and y is 1, GCD. LCM is going to be 21xy, which is going to be 189. This is 7. No, 9. So xy is 9. So can you think of an ordered pair xy 9 such that GCD of x and y is 1? There are only two ordered pairs, 1 9 and 9 1. For the first case, A is going to be 21 1 and B is going to be 21 into 9. For the second case, A is going to be 21 into 9 and B is going to be 21 into 1. So there are only two ordered cases. So answer is going to be B 2. Is this clear? Is this clear, everyone? Okay, someone wanted to go back to the previous slide. This is the previous slide. Okay, so every problem is going to have a different solution, right? And you need to know all the methods of solving, right? So we started with the standard approach only. What we did was we started a standard approach wherever GCD. So GCD, oh, where is that? GCD, let the GCD be D. But that is not leading us anywhere in this question. So we have to change the approach, and it is okay to change the approach. Is it clear? Yes, yes, I know, Nihar. Glad that you're liking it. All right. All right. So this is going to be your homework, guys. We're going to do another problem now. Oh, this is also simple. All right. Let's do this. Can you do this quickly? Quick. Okay. So wherever you see one, you mark one, is it? Okay. One thing, which is very obvious. Is this number even or odd? This is 2020 times 2021, 2019 times 2022. Is it even or odd? It is even. What about this? Is it even or odd? So of course it can't be 1, right? It can't be 3. Okay. So how do you approach problems like this? So again, these are big numbers. Again, we don't want to calculate. We don't want to calculate, find, and then. So what you do is you see all the numbers are consecutive, kind of consecutive numbers, no? So smallest number you can put as x. Smallest number you can put as x, or what you can do is middle number you can put as x. 2020. So this is like x times x plus 1 GCD and x minus 1 times x plus 2. So this GCD you have to find out. So GCD of x square plus x and x square plus x minus 2. Okay. And these are two consecutive numbers. Anyway, so this minus this is going to be 2 and x square plus x plus. We are applying the property GCD of AB is GCD of A minus B comma B. So this minus this number is going to be 2 and x square plus x minus 2. So this number is 2. So that means GCD is either 1 or 2. Because GCD has to be smaller than this number. Now this number is clearly even. And since it is even, the GCD has to be 2. Is it clear, everyone? Is it clear, everyone? Alright. So on that note, let us also solve this problem. Yeah, Nihar, see, Nihar, in this particular course, don't look at the options. That is the first thing I want to tell you. Do not look at the options because we are preparing for IOQM, right? So options are just to make life simpler for you. I want to do it the other way around to make life hard for you. So do not look at the options from next time onwards. I will also delete the options. Okay. So GCD of 5 cube plus 7 cube and 5 to the power 5 plus 7 to the power 5. So one way is a to the power n plus b to the power n. You remember from the first class? How many of you remember from the first class? A to the power n plus b to the power n is divisible by a plus b. When n is odd. Right. So this is a multiple of 5 plus 12, 7, 5 plus 7. So both are multiples of 12. My question is, if both are multiples of 12, does that mean that the GCD is 12? Yes or no? No. Yes. So basically, both the numbers are divisible by 12, but is their greatest common divisor 12? We don't know. It can be 12 or more. Yes. So GCD of this is of the form 12K. It can be 12, 24, 36, 48, whatever. So I cannot be sure about 12. So I know that both of the numbers are divisible by 12, but will the GCD be 12? I don't know. So how do I proceed? So same properties. Smaller number, big number. Small number as it is. 5 to the power 5 plus 7 to the power 5 minus something times the small numbers. What this something can be? What this something can be? So to make our life easier, I can put this something as either 5 square or 7 square. So how does it make our life easier? So 5 cube plus 7 cube here. 5 to the power 5 plus 7 to the power 5 there. It forms 5 to the power 5, no? So it is 7 to the power 5 minus 5 square 7 cube. So 7 cube common, it is going to be 7 square minus 5 square. Is it clear till here, guys? Is it clear till here? Okay. Now, guys, one more thing also you need to learn and remember in solving question like this is, can I say 5 cube and 7 cube have a GCD of 1? 5 cube and 7 cube have a GCD of 1. Yes, they both prime, no? Don't have. So that means GCD of 5 cube plus 7 cube and 7 cube is also 1. I mean, these two numbers have no number common. So can I say I can remove 7 cube from here and only do, so GCD of these two numbers is going to be same as 5 cube plus 7 cube and 7 square minus 5 square. Can I say that? Did you understand this step? For example, just to give you an example, GCD of 103 and 4 into 2785. Okay. Can I say this is same as GCD of 103 and 2785? because 4 is definitely not coming out common from this, or any factor of 4 is not coming out common from this. So whatever common, if it has to be from this number only. 4 is not giving us any common thing. Are you able to understand this? GCD of 103 and or 10 whatever 5 and 38761 or 38765 and multiplied by 2. So GCD of 105 and 2 multiplied by 38765 is same as GCD of 105 and 38765. Because 2 is not coming out common from this. So I can remove 2. It is of no use, right? Because nothing is going to common out. No factor of 2 is going to get common out. So 7 cube and 5 cube plus 7 cube are co-prime. So can I say I can remove 7 cube from here because 7 cube is not coming out, or any factor of 7 is not coming out common from this because there's co-prime. So what I'm doing is I am lowering down the numbers. Okay. Now small number is 7 square minus 5 square. You can apply the same thing. 5 cube plus 7 cube minus what times 7 square minus 5 square. Or plus what times? Why is 5 cube plus 7 cube and okay. Soham, see. Soham, did we do this thing in the morning? Not morning, at the start. GCD of AB is 1. Then GCD of A and A plus B is also 1. You remember this, Soham? Okay. So GCD of 5 cube and 7 cube is 1. Then can I say 5 cube plus 7 cube and 7 cube? GCD is also 1. Okay. Alright. So we can multiply this with 7 or whatever. So 7 cube gets cancelled out. So we have 5 cube plus 7 times 5 square. So basically we are lowering down the numbers, and similarly we keep on doing this. For example, 5 square into 12. This is 5 square into 12. 7 square minus 5 square. Can I say I can apply the same thing in 5 square and 7 square minus 5 square, because I know that 5 square and 7 square are co-prime. So that means 5 square and 7 square minus 5 square is also co-prime. So this is same as 12 and 7 square minus 5 square. This is same as 12 and 7 plus 5 is 12 into 2. So this is 12. So 12 is the right answer. So this property that we did in the morning is an amazing property, guys. Is this clear, everyone? Great. All right. So on that note, you try this question, guys. Please try this question as homework, and the rest of the questions we'll discuss in the next class. Also, do the assignment, that is assignment 3 or 4? Assignment 4. So try to complete the assignment. I have also shared the video solutions. They are going to get updated. So you can take the video solutions help also in the file shared on Telegram. All right. Any other doubt if you have, guys? Any doubt if you have? So today, guys, is a very, very, very important lecture, and all the properties that we have done in today's lecture, please follow those properties and try to apply them in the questions which are there in the assignments. And also, if you're not able to do any of the questions in today's class, just redo the questions again and try to understand them from the basic perspective, and try to apply the same trick in the questions which are there in the assignment. Yes, number theory is way too interesting. Just that the sad part is it is not given that well in NCRTs, which is really sad, right? Because numbers is something which helps us understand mathematics in a good way. And what they're doing is they're just skipping and eliminating the chapters. Tanishka, which chapter are you talking about? Are you talking about number theory? If you're talking about number theory, then you can go with the David Burton. Mathematical Circles is a kind of recreational book, which you can do parallelly with every other book. How many lectures? Soham, you can check your schedule, no? So I think there are. So we'll be doing congruence and then Fermat and Euler theorem, followed by Wilson CRT, followed by squares and primes, Diophantine equation, base system, induction we are going to do, and then a session on problem solving. So around 9-10 lectures. Yes, Mathematical Circles is an amazing book. All right. Chalo guys, take care. God bless you. Bye everyone. And I'll see you in the next class. Thank you, Shalade. Bye.